Hello, my dear viewers and my dear students. Welcome back to my math distance learning class. And in today's session, finally, we are on the last part of our series of set theory that we started a few days back. And today we are on part 8, which is going to be the last part of set theory. The lesson or the topic that we are going to be covering today is very, very important. And today in the session, we are going to work on the De Morgan's law. So today's video is going to be a must watch for all the grade 9 and grade 10 students which are going to be preparing for this topic of De Morgan's law. It's a very, very important law in the set theory, and let's see the learning objectives for the session. So in this session today, you are going to understand these De Morgan's law, and there are two laws, part 1 and part 2. We are going to understand both of them in detail, look at some examples and apply the laws to solve problems. So let's get started. Okay, so before we dive into our topic for today, that is De Morgan's law, let me give you a fun fact. So do you know that these laws were invented by a 19th century very great mathematician, and his name was Augustus De Morgan, and it is because of him today that we are going to be learning these amazing laws of set theory which are going to be really helpful for solving so many questions. Let's now understand these laws in more detail. Okay, so as I told you towards the beginning of the session today, the De Morgan laws are valid for two sets A and B, and they are of two types. This is the first law and this is the second law. So let's understand what are these laws. The first law here states that the complement, so you all know this symbol denotes your union and an opposite U denotes your intersection. These are the set operations we have already done. In case you want to review them, please refer to my previous videos. And then this one is your complement. Okay. So the first law states that A union B complement. So if you take the complement of the union of two sets, that will come out to be equal to the intersection of the complements of each set. Means what? When you take the complement of the union, this union changes to intersection, and A union B complement is equal to A complement intersection B complement. So this is very similar to if you go to your number theory and just try and relate your distributive law. So what was happening there? You are distributing the numbers over a set operation. So similarly here, when you have the set operation of union and you are distributing the complement over the two sets A union B, then the complement gets distributed to each set. So it distributes to A complement intersection B complement. So that is your first law. Let's now understand the second one. So this is a little opposite, you could say, to the first one, where you have the intersection of two sets. So A intersection B, you are taking the complement of the intersection of two sets here, and that comes out to be, then you just distribute the complement, A complement, B complement, and your intersection now changes to the union. So the second law, now I will read for you, says that the complement of the intersection of two sets will be equal to the union of the complements. So just remember, when it is union and you are taking complement, it becomes intersection. If it is intersection, you are taking complement, it becomes union. And the complement over two sets gets distributed to each set. So these are your two laws of De Morgan, and sometimes the kind of examples you're going to just see in the slides to come, you will see that it may come in an exam like, you have to verify the De Morgan's law for given two sets A and B. So let's see what kind of questions you should expect. Okay, so the first example that I'm taking here is based on your first De Morgan law. You are given here the two sets A and B. Let me highlight. This is A, this is B. So A has 4 elements. B also has 4 elements. And you also have the universal or the biggest set. It has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 elements. Now you need to verify the first De Morgan law. So you are going to calculate the left side, the right side, and then ensure that they are coming out to be equal. So we need to find both the things, A union B complement and A complement intersection B complement. So let's do this stepwise. So our solution, we are going to first calculate the left hand side. Let me write this. This is left hand side. This is right hand side. So our left hand side will be A union B. So this is my A, this is my B. Let's write the union. So I want you to recall the set operation of union. How do you write union? You take all the elements which are there in each of the set, but you don't repeat the sets elements which are common. So the common one, let's highlight, maybe I'll use a different color here now. So C is common in both, and so is E. So C and E are going to be just coming one time, and the remaining elements you can put in here for the union. So A, C, E, B, D, E, and G. So 1, 2, 3, 4, 5, and 6. So your union has 6 elements. Okay, now we have got union. Let's take complement, and I want you to recall the definition of complement. So if you have any set, for example A, and you're trying to calculate A complement, so you simply subtract from the universal set that given set. This is the definition of complement that you already know from the previous videos on set operation. So A union B complement would be your universal set which has 8 elements, and then from there you just remove the A union B. So 8 minus 6 elements, so definitely it will have 2 elements remaining which are F and H. So we have got our left hand side which has 2 elements. Now let's do the right hand side. So to get the right hand side, we'll first calculate A complement, then we'll calculate B complement, and finally we will take the intersection. So let's write A complement and B complement. Very easy. We are going to use the basic definition of complement and do the set subtraction. So this is how my A complement and B complement looks like. Now let's find and highlight what are common here, because we are taking the intersection. So to get A complement intersection B complement, this is the intersection, we have to by definition take the common element. So let's see what are common elements here. So F is definitely in both the sets, and H is also in both the sets. A, B, D and G are different. So my intersection would also be having these 2 elements. So I hope now you can understand that observation, that your right hand side has also 2 elements F and H, your left hand side also has 2 elements F, H. So notice these 2 sets have come out to be equal, and that is what illustrates or verifies your De Morgan first law. So this was an example where you applied the first law and verified it as well. Okay, so let's now see example 2. This question will be solved using De Morgan's second law. Here in the question, let me read it out for you. You are given all 3 sets, the universal set, the set A, and set B. So let's count the number of elements. Both set A and B have 4 elements, and the set U has 1, 2, 3, 4, 5, 6, 7. So it has 7 elements. Now to verify the De Morgan's second law, we have to calculate the left side, the right side, both of them one by one. So let's first find A intersection B. So to get to your A intersection B, you need to find the common elements. Let's see what is common. 12 is common for sure. Then you have 13. So your A intersection B would come out to be 2 elements. Now you need to take the complement. So to take complement, by definition, you need to subtract it from the universal set. That means from the 7 elements, you are subtracting 2 elements. So it will have 5 elements in set of complement. So A intersection B complement, you're just removing 12 and 13. So if I remove these 2 elements, 12 and 13, I'm left with 10, 11, 14, 15 and 16. So this is your left hand side. It has 5 elements. Let's now calculate the right hand side. So for that we need A complement, B complement, and then we'll take the union. So for A complement, you have by definition, using set subtraction, you will subtract the set A from U, and for B complement you will subtract the set B from the universal set. So your A complement and B complement would have 7 minus 4, that is 3 elements each. So this is what you are going to get for the two sets. Now we just need to take the union of these two so that we could get A intersection union B complement. So let's take the union, and we are not going to be repeating the elements which are common in both, so it will have the same 5 elements. So that you can notice now both the sides, the left hand side and the right hand side, have come out to be equal. So your A intersection B complement and A complement union B complement are equal, and that's what proves your De Morgan's second law. Okay, so let's do one guided practice question now. Let me read it for you. Let U be this set, so it has 1, 2, 3, 4, 5, 6, 7, 8 elements. A is this set which has 4 elements, B also has 4 elements. So quite similar to the last one. Here we are trying to check about these two sets. So let's do that one by one. So first I'm going to be taking A union B. Okay, we are going to calculate this set. So because I'm taking union, I'm going to write all the elements which are there in both A and B, and if there is any repetition, then I'm not going to be repeating it 2 times, I will just write it 1 time. So let me highlight with a different ink. NBC, this is common in both of them. Then you have Fox, which is also common. USA, TBS, nothing else is left. So we will just write NBC, FOX, because they are coming 2 times, so I'm going to write them 1 time, and the remaining elements. So USA, TBS, ABC and CBS. So let's count now how many elements. 1, 2, 3, 4, 5, 6. This has got 6 elements. Now I need to take the complement. So A union B complement, by definition of complement, would be the universal set minus A union B. So from this set of 8 elements, I'm going to remove the 6 elements. So definitely there will be 2 elements which will be left. So let's find which are these 2 elements. So I'm going to just put a comma. So I'm going to be using a yellow color here. So I'm going to remove A union B from this set. So NBC, this gets cancelled. FOX gets cancelled. USA also is gone. TBS is removed. ABC and then CBS. So I'm just left with these 2. So that tells me that TNT and MTV, these are going to be the 2 elements in this set. So I've reached to this part. Maybe I can write LHS. I have reached this part. I need to now check the other one, and then we need to observe are these equal or not. So let's now calculate A complement and B complement. So that in the next step I would just do the intersection to get this set. So by definition you are going to be doing the set subtraction to reach to these 2 answers. So from the universal set of 8 elements, I'm removing the 4 elements. So I will be left with 4. Let's see which 4 will be left. NBC is gone. ABC is left. Okay. And then CBS is also left. Fox is gone. USA is gone. TBS is gone. So TNT and MT. This is my A complement. In a similar way, let's write B complement. So from the 8 elements, I remove the B. So I'm left with USA, TBS, TNT and MTV. Now I will take the intersection. That's the last and final step for the right hand side. So to reach to my intersection, I will change color. ABC is not common. CBS also is different. So we can easily see that only 2 elements are common, which are TNT and MT. So now I want you to make that important observation. So your left hand side, which was A union B complement, has come out to be this set having 2 elements. Your right hand side, which was A complement intersection B complement, has also come out to be the same value. So now we could deduce that these two sets are going to be equal. That's the observation we will make, and so we can now verify and just write that A union B intersection is equal to A intersection A complement intersection B complement. So we verified the De Morgan law. Okay, so let's test your understanding now. So this is another question which I want you to try yourself, very similar to the last one which we just worked upon in the guided practice question 1. And you will check your answer, and in this one you have to verify the De Morgan's second law, and both the sets also will come out to be equal. Please try and put in the comment section if you have any queries or questions. Okay, so that brings us to the end of today's session. With this video, we have completed all parts of the unit that we started, set theory. I urge you to revise today's session, and until the next video, see you. And don't forget to like, share and subscribe to my channel if you found the video useful. I will be waiting for your comments and questions in the chat box. Bye-bye.